This is an example circuit of wiring up the stepper motor to the Arduino. So to do this, you'll need your Arduino board, your line driver, which is this just for reference, and then your stepper motor. In this circuit, we have pins 8, 9, 10, and 11 wired to pins 1 through 4 on a line driver. So we go digital pin 8 to pin IN4, digital pin 9 to pin IN3, pin 10 to IN2, and then pin 11 to IN1. And these pins IN1 through IN4 are right here on your line driver. We'll then connect 5 volts to common and then ground to ground on a line driver. So over here on this line driver, you'll connect ground to the pin right above the minus, and you'll connect 5 volts to the pin right above the plus. To plug in your stepper, you'll plug in the stepper right here in this white socket. The first thing to do is, if you don't have Arduino IDE installed, is go ahead and install that on your computer. To do that, just go to Google or whatever search engine you use and look up Arduino IDE. Click on the first link, and then over here are your download options for whatever operating system you have. It'll go through the download process, it'll install it, and then once it's installed, go ahead and open it up and follow along with the code that I have shown here. To get the code ready, the first thing you need to do is to include the stepper library. So that's the first line of text here, first line of code. To include it, go to Sketch, Include Library, and then find stepper in the list. If you do not see stepper in this list, that means the library is not installed on your Arduino yet or in your Arduino IDE. So to install it, just go to Tools, go to Manage Libraries, and then search for stepper in this bar. It'll be the first one to pop up. Where mine says remove, it will say install for you. So click on install, that will install a library, and now you'll have the stepper library installed. To get rid of this menu, just click on this right here, and that menu will go away. So once you installed it, then make sure to include it. So again, to include it, go to Sketch, Include Library, and then click on stepper right there. And once you click on it, this line will pop up. After including the stepper motor library, we'll do some initialization of variables. So these 4 lines of text or 4 lines of code here, I use to initialize these 4 variables. So stepper 1 steps, stepper 2, and stepper 2 steps. They're initialized as string variables, which means that they'll be having text values saved to them. So this text will be saved to those variables. Once we initialize those, we'll move down to initialize a constant integer variable of steps per revolution and set it equal to 2052. We say that because our steppers take approximately 2052 steps to do 1 full revolution. We'll then move down to actually initializing the variable or the steppers themselves. So we'll say stepper, my stepper 1, stepper, my stepper 2, where my stepper 1 is the variable that corresponds to my first stepper, and my stepper 2 is the variable that corresponds to my second stepper. We'll say my stepper 1 equals stepper, steps per revolution, and then where it is on the board, what pins it is plugged into. My first stepper is in pins 8, 9, 10, and 11, like shown earlier in the video, but in IDE, you need to tell it 8, 10, 9, 11. If you don't, it will run a little awkwardly, or it may not work at all. So make sure you tell the Arduino where it is in this configuration. Same thing for my second stepper. It is on pins 4, 5, 6, and 7, but in IDE, you need to tell it 4, 6, 5, and 7. With all those initialized, we'll move down into actually running the code. So void setup will just run once. So whenever you give the board power, this will run once. So we're going to tell it to serial.begin 9600. We're going to say look for communication at a baud rate of 9600. That's just the default rate for MATLAB. So we're going to tell it to look for that. And then we'll say my stepper 1 set speed to 10, my stepper 2 set speed to 10. We're just setting the speed for those steppers. We'll then move down to the void loop. The void loop is going to run over and over. It's basically a big while loop that runs as long as the board has power. What it's going to be doing is going to be looking for communication. So it's going to say if serial available is greater than 0. What that means is, have we sent data from MATLAB yet? So if we've sent data from MATLAB, if it's getting communication from MATLAB, it's going to do all this stuff inside the void loop. If we've not sent anything, it will not do anything. So if we've sent communication from MATLAB, like if we sent a string over from MATLAB, the first thing it's going to do, it's going to say stepper 1 equals serial read string until comma. So what that means is we're going to send a string over that looks something like this. So I'm going to show MATLAB later in this video, but this is an example of the string we're going to be sending over. So we're sending over a delimited string where our commas are our delimiters. All that means is that the code is going to be looking for the comma and know to use it as a space or a pause between numbers. So we're going to say, read this string until we see a comma, and then take the data right before that comma. So stepper 1, it's going to say equals serial read string until comma. So go back to this example. It's going to read this string until it sees this first comma and save this number to that first variable. Stepper 1 steps will now read the string where this first one left off. So it's going to go back to the string. The first one read until this point. So now that second line is going to read where the first one left off. So go from 2000 to this comma. So it'll save this 2000 to that variable. Stepper 1 steps. And then this line of code converts this variable from a text value to an integer value, to an actual number. So it takes it from 2000 as a text value to 2000 as a number value. And I'm only saying 2000 because of this example here. We'll then take steps for stepper 1, which is a number of 2000 in this example. And we'll tell our first stepper to move that number of steps. After it's moved, we'll reset it to 0 just so it doesn't move anymore. Now our second stepper, we're going to say read string until comma. So it'll read where the last read string left off. So again, the last read string left off right here. So it'll read from this comma on until it sees another comma. So it'll read from here right to there. And it'll see that 2. I'll save that 2 to stepper 2, and all that's doing is just saying this is our second stepper. And in stepper 2 steps, we'll again read until it sees the next comma. So that last read left off right here, and so it'll read again until either the end of the string or it sees a comma. So there's no comma at the end of the string, so it'll just read to the end. Finally, we'll convert again steps for stepper 2 from a number or from a text to a number. So this is integer steps for stepper 2 steps to integer. So we're just converting this from a text value to an actual number. And then we'll say my stepper 2 dot steps will move my second stepper however many steps we just said in that last string, and then we'll reset it to 0. So again, what this is doing is it's reading the string until it sees a comma, and it's saving the number right before the comma, and it just runs through that string, saving all of our variables where we need them. Once your code in IDE is written and you're ready to upload it to the board, the first thing to do is to verify that the code is done with no errors. To do that, come up here to this check mark that says verify, click on that. Arduino will compile it and look for errors. Since it said done compiling and did not show any error messages, that means there's no errors in the code, which means this code is ready to be uploaded. To upload it, first do this drop down, click on Arduino Uno right here. Your COM may be different, maybe COM 4 or COM 3, that's fine. On mine it's COM 7, so I'm going to click on that, and then click on this arrow to upload it. It'll again say compiling sketch at the bottom, and then when it says done compiling, that means the code is now uploaded to the board. So now that our code is uploaded to our board, we can go ahead and go into MATLAB and use MATLAB to talk directly to our steppers. First thing to do in MATLAB is clear everything out in case there's already a connection from past code. So we'll do CLC, a clear, and a clear S. We'll then move down to declaring where the serial port is. So S equals serial port, COM 7, using a baud rate of 9600. Your COM may be different than mine, so to check that, go to Arduino, click this drop down, and look right here, mine says COM 7. Yours might say COM 1, COM 2, whatever. If it does, that's fine. Just go to back to MATLAB and then change where mine says COM 7 to whatever yours is. We'll then pause the code for 2 seconds to allow MATLAB to connect to the port. Then move down to declaring variables used to control the steppers. So my steps for 1, that's my variable to control my first stepper, and my steps for 2, that's the variable to control the steps for my second stepper. and I just have 2000 and negative 2000 as arbitrary numbers. They're just for example. This line of code is what builds the string we need for Arduino to move our steppers. So to remember, for example, using the 2 steppers, we need a string that looks like this. So 1 is that first stepper, comma, the amount of steps to move that stepper, comma, 2 is the second stepper, comma, and then the amount of steps to move that second stepper. So we need a string that looks like this for the code to work. So that's what this line of code does. It compiles that string and gets it ready to send it over. So real fast, I'm going to run this code just so we can see what this string looks like, and we can see that it does match up. So I'm going to run the code, and then when it stops, I'm going to copy and paste this variable down to my command window and hit enter, and then we'll see that this is the value that that variable holds, and we'll see that it is in that same format we want. So the 1, comma, steps, comma, 2, comma, steps. So that's good. So now we'll send that variable over to the Arduino. So we'll use write. We'll write to the port, the serial port we declared up here. We'll write that variable, and then we'll just say, hey, we're sending a string value over. So this will send that string over, and it'll move the steppers as far, however many steps you told them to move. So when you run the MATLAB code that we just walked through, these steppers will move. You'll notice how the first stepper will move and then stop, and then the second stepper will move. So they move sequentially. So the first one moves, stops, the second one moves. That's the way that this code works, is it does first and then second. So very quickly, the code here in Arduino and the MATLAB code were both developed to move 2 steppers on one single Arduino. If you want to add a third one or more steppers, you can, as long as you have room in your digital pins to do so. So let's say you wanted to add a third stepper. You would come up here, you'd make variables for that third stepper. You would tell the Arduino where that third stepper was. You would set your speed for the third stepper, and then you'd come down here and add to this code to make it so the third stepper would be moved. Same thing in MATLAB. You'd make a new variable for that third stepper and then add the appropriate parts to this code to make it so the third stepper was moved as well. So you can add more steppers to this code if you need. This code was just developed to move 2, and then B is an example to move multiple steppers using one Arduino.